A positive correlation between two variables x and y occurs when high measurements for the x variable are associated with high measurements for the y variable, and low measurements for the x variable are associated with low measurements for the y variable. Female height weight example is an example of positive correlation because high measures of the x variable are associated with high measures for the y variable. And low measures for height are associated with low measures for weight. Let me give a visual of this. Where is it? Okay. If we take a look at the low measurements for height right here at the left side of the horizontal axis, the low measurements for height 58 to 60 are associated with low measurements of weight, about 100 to maybe 110. That's what these dots show down here. Then we have high measurements of height up here in the 70s associated with high measures of weight around maybe 150 to 160. And so we have low measurements for x corresponding to low measurements of y, high measurements of x corresponding to high measurements of y. And that is why we have a positive correlation. The appearance of a positive correlation is one in which the points move upward towards the right of the scatter diagram. Okay, so what you're going to see is as you move your eyes from left to right is the points generally moving in an upward direction. If we approximate a line through the dots of the scatter diagram, we see that they follow a straight line path. So we can position a perfectly straight line among the points, so somewhere in the middle of those points, and we're going to see that these points generally move upward from left to right, okay, because that line is sloping upward from left to right. When we use the word linear in mathematics, we're talking about a relationship in which the graph forms a straight line. So a linear relationship has a graph that forms a straight line. Let's look at negative correlation. A negative correlation between two variables x and y occurs when high measurements for x variable tend to be associated with the low measurements for the y variable, and vice versa. The low measurements for the x variable are associated with high measurements for the y variable. This is an example of negative correlation, and students often make a mistake of thinking that negative correlation means no correlation, and that's not true at all. A negative correlation can be a very strong correlation. It's just in the opposite direction from a positive correlation. So again, our horizontal axis is labeled from low to high. Low measures of x are associated with high measures of y. Okay, so these dots up here have x values that are low and y values that are high. Then high measurements of x are associated with low measurements of y. So these points over here have high x and low y for their coordinates. Because remember, the vertical axis is also labeled from low, starting at the bottom, to high. No linear correlation when there's no relationship between the two variables. That is, high and low measurements for the two variables are not associated in any predictable straight line pattern. So again, like dropping cereal on the floor. Everything goes every which direction, nothing's got a necessary pattern. If you put a line through these, you don't generally see the points moving upward from left to right or downward from left to right. There's no linear correlation here at all. Okay, so we're going to see that when we look at sample data, and our sample data tends to form points that go upward from left to right, we're going to see a positive correlation, which could be strong correlation. If our points tend to group downward from left to right, then we'll say we'll have a negative correlation, which could be just as strong as a positive correlation but in a different direction. And when they don't have any grouping at all, we have no linear correlation, like this one right here. Okay, so let's look at an example. Suppose two variables being studied are x, the length of time spent playing Pac-Man, and y, the player's score on the game Pac-Man. Do you believe the variables have a positive, negative, or no correlation? So the length of time is x and player's score is y. So imagine getting a sample of data, getting a sample of players, and measuring x for each player, the time spent, and y for each player, the score. Now, if you were to plot each of those points on an x and y axis, do you feel that the points would be moving upward from left to right, downward from left to right, or do you think that there would be no correlation at all? Okay, so the answer to this question is that the more time spent playing Pac-Man, the higher the player's score will get. And similarly, if very little time is spent practicing, which is x, the player's score will be low. So what kind of correlation does this refer to? This is a positive correlation. Low values for the x variable are associated with low values for the y variable. High values for the x variable are associated with high values for the y variable. We have positive correlation. So imagine that you have a horizontal axis for x, length of time spent playing Pac-Man. You have a vertical axis for y, player's score on the game, and you notice that if a person doesn't spend too much time, low x, they don't have a high score. But if they spend a lot of time, they'll have a high score. And generally the points will move upward from left to right. Now, could you have outliers in your sample? Absolutely. You may have outliers in your sample where there may be the person who spends hours and just gets worse. But for the majority of people, this is the relationship that is expected. You spend time and you get better. So when you answer this type of question, don't think about outliers necessarily, but really think about for the majority of the population. What would the correlation be? Okay, let's look at another example. We have two variables, x, the length of time a student misses class, and y, the student's class average. Okay, so let's imagine what we have here. X on the horizontal axis, length of time a student misses class. So if a student misses very little class, we are on the left side of the horizontal axis. If the student misses a lot of class, we are on the right side of the horizontal axis. Y, the student's class average. If the student's class average is low, we're at the bottom of the graph of the y-axis, and if the student's class average is high, we're at the top. So think about the time spent missing class and the student's class average for the majority of students. You've got the outliers that you can consider, but for the majority of students, what do you think the relationship will be? So let's give some justification to the reasoning here. If we spend a lot of time missing class, x, which means that we're over here on the right side of the horizontal axis, the lower a student's average will be. So low values for y, because they aren't learning the material. Similarly, if less time is spent missing class, so we're on the left side of the horizontal axis, then the student's average will be higher, which is up here. So you group those points and they will be moving downward from left to right. Since the high values for the x variable are associated with low values for the y variable, the low values for the x variable are associated with high values for the y variable. We have negative correlation. So our graph is going to be moving downward from left to right. Our points generally are going to be moving downward from left to right. Okay, let's look at